today's lecture we'll see about the communication cost in the parallel machines. Okay, so the communication cost, if you are considering, it is nothing but the one of the major overhead in the executions of the parallel program arise from the communications of information between the processing elements along with idling and the contention. So communication is considered as a major overhead because what happen in net if you in parallel system, if you want to communicate with the other processing nodes, okay, so it may be happen that due to some network topology, what kind of layout you are going to be used, uh, uh, see what type of connections you are going to be implemented, what kind of approach you are use for the communications purpose. There are lots of parameters are there. Okay, so the cost of communication is depends on variety of the features, including the programming model semantics, the network topology, of कौन सी network topology use कर रहे हो, how you are going to be handle the data while you are sending the data into a network and routing the data. So routing the data is nothing but the source. You are sending the data from source to destinations in a network. So what happen? So the properly, if there are number of hooks are present or the different nodes are present in between source to destination, so how the data will be travel from different nodes in the network and it will reach to the destination. Then according to that, different routing algorithms are there. Here for parallel system, we'll see the two routing algorithm. One is the store and forward routing algorithm, and second one is the cut through routing algorithm. And then there's some associated software protocols like your Snoopy protocol or the directory based protocol to handle the cache coherence, okay, problem. So first we'll see the message passing cost in the parallel computer. Okay, so the message passing cost is nothing but the say cost. If you are considering the communication cost is nothing but the latency. Okay, actually, because you want to send your message from source to destinations. Okay, so how much time it is taken for reaching to the destination, that is nothing but the latency of your network कि उसे कितना टाइम लग रहा है to reach to the destination. Actually we are considering as a communication cost is nothing but the latency, कितना देर से वो आपका मैसेज रीच हो रहा है. So the time taken to uh, communicate a message between a two nodes in a network is the sum of the time to prepare a message for a transmission and the time taken by the message to traverse the network to its destination. Okay, the message passing cost is nothing but the it is the time we are taken to communicate between the two nodes. So कौन सा time यहाँ पे consider करता है? So or time to transfer a message, okay, and prepare a message for the transmission and the time taken by the message to traverse the network to its destinations. Actually, two things were considered here for calculating the message communication cost. So first point is when you are sending the message, okay, you need to prepare the message. Actually, you having the message, okay, your original data, but with the original data, what we are going to add, we are adding some more details with this your original data. Okay, so what are the different details are there? Actually, your header information, routing informations are there. Okay, so you are going to add this one. So that is nothing but the first step we are calling as a preparation of a message for sending from source to destination, and the second parameter is considered as a time taken by the message to traverse. Okay, that is the total time. So actually the whatever the message preparation time is very small in a size. Okay, in a size we can consider. So sometime it is considered as a neglect or we can neglect that particular time. Okay, So the latency of message passing is calculated or depends on these three different principal parameters. One is considered as the startup time, second one is a per hop time, and the third one is considered as a per word transfer time. Now, what do you mean by startup time? So the startup time is the time required to handle a message at the sending and receiving node. So the time spent at a sending and the receiving nodes. Okay. So you are going to send the message from your source to destination node. So before that you need to prepare the message. Okay. So what we are going to at the time of preparations of the message, what we are going to be add, you can add the additional information with the original data, that is nothing but the header, tailor, and the error corrections informations you are going to be add at the initial level or at the source. Then second thing is the time to execute the routing algorithm, and third one is the time to establish an interface between your local node and the router. Okay, so that is nothing but your startup time. So what we are considering in the startup time, we are considering the preparations of your message. तो प्रिपरेशन में क्या क्या आ जाएगा आपका कि आपको ऐड करना है. सेकेंड थिंग इज यू कैन एग्जीक्यूट द राउटिंग algorithm, उसको कितना टाइम लगने वाला है. एंड थर्ड पैरामीटर you can consider that time to establish an interface between your local node to router. So these things are considered in a startup time. Okay, but this startup time is occur at only once when you are preparing a single message for the transmission purpose. Okay, जब आप you are going to ready to transfer your message, so this startup time is occur at a single time. Okay, so hope you are getting this. Startup time is what? Then per hop time. So this time is a function of a number of hops and include the factors such as the switch latency, network delay, etc. Okay, see, once you prepare the message, okay, now you want to send the message to the destination. See, in that case, it may be happen that in your network only source and the destination nodes are present, only these two nodes are present. So you can we can say that there is a direct link in between your source and the destination. But it may be happen that in between your source and destination there are different nodes are present. Nodes are system, or we can consider as a hop. In network we are considering as a hop. So after a message is leave a source node or a local node, so what happen, it will take a finite amount of time to reach the next node. जो भी पाथ आप लोगों ने डिसाइड किया हुआ है for sending the your message from source to destination, in that one some time is taken to transfer the message from one to another node. Okay, so that time is nothing but your per hop time. So the time taken by the header of a message to travel between two directly connected nodes in the network is called as a per hop time, or in simple we can also call as a uh, uh, this kind of latency, because कुछ तो टाइम लग रहा है आपका मैसेज ट्रांसफर होने के लिए फ्रॉम वन होप टू अनदर होप. So we are calling as a node latency. Okay, see, hope is also called as a node. So from one node to another node, data transfer हो रहा है आप लोगों का. Okay, so it will take some time. See, that time is in a millisecond. Okay, but we are considering that is nothing but the latency. And why this latency is occurred in between this node? Because due to switch latency. Okay, and the network delay, that two parameters are considered for calculating the per hop time, or these are the example for the per hop time. इसका जो भी latency रहेगा या फिर network delay हो जाएगा. Okay, network delay is also considered as a node latency. Then third principal parameters for latency we are considering as a per word transfer time. So this time include all overhead that are determined by the length of the message. Okay. Now here in a startup time, what happen in each for each message, okay, say if there are some number of messages you are going to be transferred, so for every message you are preparing the some overhead is nothing but routing informations you are adding, then the header, tailor, and the error corrections code, your error correction informations you are going to be add to each and every message. So that is nothing but the extra burdens you are going to be add to your each and every message, or we can say that the overhead is going to be assigned to each and every message. So it now this per word transfer time this depends on the length of the message. Okay, this include the bandwidth of link, error checking, and the correction etc. So if the channel bandwidth is r word per second, then each word takes a time that is 1 divided by r to traverse the link actually. Okay, so here we are considering these three principal parameter for calculating the message passing cost, okay, in parallel system. For hope we are getting this one. First one is startup time. So three basic things are considered. One is the preparations of a message. Then second one is execute the routing information, and third one is time to establish a interface or the connection in between your local node and the router. Per hop time is nothing but the when the message is transferred from one node to another node, the time is taken, finite time is taken, and that time is nothing but your per hop time we are considering. Okay, and per word transfer time is depends on your the length of the message. Okay, and the what kind of overhead you are going to be added into the message.